Okay, let's briefly explore the hyperbola. Now, the hyperbola is one of the conic sections, as you can see here. You can see how it's formed there with a plane cutting down through these cones. And here's a picture of a hyperbola. Now, this particular hyperbola has what we call a horizontal transverse axis. And what that means is it's on this horizontal axis where you have what's called the foci. Okay, so this is a focus, and also the vertices, and there's also a center point here. Those are the things that we're going to be looking to find. But before we go any further, I need to tell you what a hyperbola is. A hyperbola is a set of points that have a particular quality about them, a particular characteristic. And let's see if we can determine what that characteristic is. Let's suppose that xy is one of the points of this hyperbola. If we go from this focus up to that point, that's a distance, okay? So there's a distance there. And then if we go from that point down to the other focus over here, that's a distance too. Now, it doesn't matter what the point is. This is just some arbitrary x and y. If we take the difference of those two numbers, those distances, this d1 minus d2, that distance is equal to some constant. And that constant is going to be the same no matter which point we choose on this hyperbola. Well, the union of all those points that have that property form the hyperbola. That's what a hyperbola is. Now, what we're going to pay attention, now you can look, before we go any further, here's one where it has a vertical transverse axis. And still you have the foci, still you have the vertices, and it's a hyperbola. It's just oriented a little differently. Instead of a horizontal transverse axis, you have a vertical transverse axis, but still the definition applies to this. You've still got the distance here, and it's got the common difference of those distances. So before we go any further, let's just see if we can look at a graph of a hyperbola and kind of get an intuition about how these things behave, how hyperbolas behave. And what I've done is I've just put in a standard model for a hyperbola here that has a horizontal transverse axis. I've got x squared over a squared minus y squared over b squared equals 1. And this particular hyperbola is just centered at the origin. Now, of course, we could do vertical and horizontal shifts and move the center wherever we want it, but that won't change the behavior of the hyperbola. It just changes the location. Notice here that I've got a slider for A and B. So here's A and here's B. And what I want to do is just kind of adjust these sliders so you can see how that changing those values on the bottom of x squared, changing the values on the bottom of y squared, what they do to the shape of the graph. Now, first of all, I'm just going to keep B fixed. In other words, what's on the bottom of y, I'm just going to keep it fixed. And notice how I increase A, what happens? See how it kind of spreads the hyperbola out, right? It pushes that vertex out. See how it does that? Pushes the vertex out. So now in particular, notice this, that when A is 1, the vertex is at 1, plus or minus 1. When A is 2, the vertex is at plus or minus 2. See how that looks? So now A is 6, the vertex is at plus or minus 6. So you can see A is going to kind of determine where your vertex is. Now, let me just keep A fixed here and let me adjust B. Okay? Now notice B is the same as A at this point. Okay? So notice B is 2 and A is 2. Now, let's take a minute and look at the slope of these asymptotes. Now, I haven't said much about asymptotes, but what an asymptote does is it kind of models the behavior of the hyperbola for the extreme left and right values for x. In other words, it's the line that the hyperbola will start to hug up against as x goes to infinity or as x goes to negative infinity. So notice you have two asymptotes. You have the positive slope asymptote here and the negative slope asymptote here. Those asymptotes cross through the origin. And let's just take a minute and take note of something. Look at this. You got B is 2 and A is 2. And look at the slope. You go over 2 and up 2. That slope is 1. Okay? Look at that. The slope is 1 here. It's -1 over here. Now let me double b. So now you've got b is 4 and a is 2. Now notice what happened. See, here was the hyperbola when a and b were the same. Now if I double b, the number under the y, if I double that, look what happens to the slope of these asymptotes. Now the slope is 2. See? 4 over 2. So the slope is 2. What if I move it up to 6? Now look, b is 3 times a. And look at the slope over here. It's now 6 over 2, which is 3. So your slope, so you can see how your slope is going to depend on the number on the bottom of the y squared and the number on the bottom of the x squared. That's going to, the slope of your asymptotes are going to be related to those. And in fact, the slope of these asymptotes are always going to be b over a for the positive one and negative b over a for the negative one. That's the way these asymptotes are going to be. Now, realize I'm using b as just on the number on the bottom of y. Here's the thing. The slope is going to be the square root of the number on the bottom of y, the y squared, over the square root of the number on the bottom of the x squared. And I'm calling them b and a here. But it's going to be this number down here, the square root of it, over the square root of this. So in this case, it's going to be 6 over 2. See? Just because I'm calling the number on the bottom of x squared a squared. Okay. Now, another thing, notice this, that the focus, look what happens to the focus, is I keep a fixed and I move this b. I'm making b bigger and bigger. In other words, b is getting further and further from a. Look what happens. The focus is getting further and further from the vertex. See how this looks? The hyperbola is getting steeper and steeper, and the foci are getting pushed out. See, here's a focus and here's a focus. But anyway, I don't want to belabor this. This is something you can explore with Desmos. I'm just trying to give you a little bit of an intuition about how these hyperbolas behave. Okay, so let's look at an example. Here is a model for a hyperbola. Now, this is what it looks like. And you notice that down here you can see where the vertices are going to be. You can see where the center is going to be. But what I want to do is go through and look and see, well, how do we find each of these parts? The center, the vertices, and the foci. Well, first of all, the center is going to be 2, -4. Notice, if we just had x squared over 9 minus y squared over 16, the origin would be the center. But we have a horizontal shift of 2 to the right and 4 down. See? So remember, the way we get the center is something that's familiar to us. We get the x-coordinate from the parentheses with the x, only opposite. The y-coordinate from the parentheses with the y, only the opposite. Now, as far as the vertices go, okay, we're going to take the center. Now, because it's the x part that's positive, because of that, that's how we know it has a horizontal transverse. That's how we know that to find the vertices, we're going to add to the x because the x is positive. Okay? Notice the negative is in front of the y square part. The positive is the x square part. So everything is going to be done to the x. So look at this. I'm going to add the square root of 9 to the x. And I get one of the vertices. And then I subtract the square root of 9 from the vertices. And I get the other one. Okay? So there's my center and my 2 vertices. So because we have the horizontal as the transverse, we're adding to the horizontal component. Now, as far as the foci go, we're always going to use this to find the foci. We're just going to add this to this, the 9 plus the 16, whatever's on the bottom of the x squared part to what's on the bottom of the y squared part. We add those together and then take the square root. And in this case, we find that C is 5, and that's what we add to the x-coordinate and get one of the foci, and then we subtract it from the x to get the other foci. There we have it. So those are the important parts. Now, what we need further, we need the asymptotes, and I want to show you how we get those asymptotes. We've got this model right here. This is our hyperbola. Now remember, when we talk about asymptotes, we're talking about what happens as x goes to positive infinity. What happens as x goes to negative infinity. So I'm going to see if I can figure that out from this model. But what I want to do first, really, I want to find out what y does as x goes to infinity. So what I want to do first is see if I can solve for y here. So I bring this, I just keep my y square part on one side and move everything else to the other. So this is what I have here. Okay. Then I multiply both sides by 16. See? So that's what I got here. See? Just multiplied through by 16. Now, I want to take the square root on both sides. Now, if I take the square root on this side, here's what I did. What I did here is I factored out a 16/9 from here and from here. But you might say, well, there's no 9th there. Well, that's what this 9 is right here. Now notice, if I multiply through here by 16/9, I'll get 16/9 here minus 16 here because the 9s would cancel. So in other words, I went from here to here, and what I did was I factored out the 16/9. Now the square root of 16/9 is 4/3. Okay, so here's what I got. You might need to take a minute and figure out what I did here, but I think after you look at it for a minute, you'll see, oh, he just factored out. There was no 9 here, so I had to put a 9. There was no 9th, so I had to put a 9 up here to counteract when I multiplied through. Okay. Now, notice that I did an additional step here. Well, first of all, I brought over the -4. Almost got ahead of myself. But notice, I'm going to do something in here. Okay, so from here to here, I just brought over the -4. But what I'm going to do here is I want to factor out this x minus 2 squared. See? I just factored out because, so now in place of this, there's a 1. And then over here, there's the 9. And to counteract for the fact that I factored it out, I put an x minus 2 squared here. So now notice, if I distribute this x minus 2 squared through here, I get this exact thing back. But the reason I did this is because, remember, we're saying, well, what happens as x goes to infinity? Positive infinity or negative infinity? Well, look what happens. This term right here goes to 0 because I've got 9 over this growing thing. This down here gets huge. So what I'm left with is just the square root of x minus 2 squared, which is the absolute value of x minus 2. This right here is what gives you your asymptotes. Now you can write this a little bit differently. You could say, well, I'm going to write that as y equals -4 plus 4/3 x minus 2. And I get that. And then I'm going to represent the other as -4 minus 4/3 x minus 2. And I get that. Those are your two asymptotes. Now notice, you don't have to go through all of this business right here to get these two equations. Notice all I had to do, notice I've got y plus 4. I could just put -4 right here. The square root of what's under y here over the square root of what's under x here, and then x minus 2. Anyway, I'll try to generalize that a little more here in a minute. But there is your what we need. The center, the vertices, the foci, and the asymptotes. Now let's look at this one. Here you have the y part now that's positive. So it's going to look like this. Now we have a vertical transverse axis. So what we're going to do is we're going to add to the y coordinate. So here's the center. Okay, the x from the parentheses with the x, the y from the parentheses with the y. Only the opposite of what they appear in the parentheses. Okay, there's the center. Now the vertices, we're going to add to the y this time. See, I'm adding to the y because we're having to go up, right? We're not going left and right. So I add 3, right? What's on the bottom of y? I add that to the y. And I subtract it. Now we also want the foci, and we have to find the c part. So I add the 9 and the 16, take the square root, and I get a 5. And now we have the foci. Now I want to get the asymptotes. Now I could go through the same process here that I did previously. But what it's going to amount to is I'm going to get, notice, I got 3 over 4. Notice, what's on the bottom of y over what's on the bottom of x? See, 3 over 4, x minus 2. See that, x minus 2? And then negative 4. Okay, so I get that, and I get this one, 2 asymptotes. So notice, you may need to take a minute to study where I get these numbers, because you don't want to derive it every time. And in just a second, I'll generalize a little more. Okay? So look, let's look at this example. Here we have horizontal transverse axis. Looks like this. Here I've labeled the parts we need. We need the center, the foci and the vertices, and the asymptotes. HK is the center. Now, this right here, H minus A, comma K, that's going to be the vertices. That's going to be a vertex here. And then we add 1, and we get the vertex here. So these two right here, that's this and this. See? Now, we calculate C. It's the square root of A squared plus B squared. And we get H minus C, that's this. H plus C, we get this. Now, dig the asymptotes here. Here's what's going to happen. The asymptotes, notice, we take the K plus or minus B over A, and then this thing, X minus H. Those are the asymptotes. The plus and the minus. See, the positive and then the minus. Now, if we look at this one, now notice this one has a vertical transverse axis. Vertical. Okay? So it's going to look like this. And still, we've got the same center, HK, the same C, but look at this. Here is the vertices, H comma K minus A, right there. Notice I've got A now on the bottom of the Y. And then there's K plus A right here. We've got the foci, K minus C and K plus C. See? Plus C minus C. And then the asymptotes. Notice K, what's in there with the Y, only the opposite. See? And then what's under the Y over what's under the X. Of course, the square root of those. And then X minus H. See? See the similarity. And you get the positive slope, the negative slope asymptote. Now let's suppose that we have a hyperbola like this one. And we're asked to find the center, the vertices, the foci, the asymptotes. Well, it's not so easy just to look at this and glean any of that information. So what we want to do is we want to put it in the form that we're accustomed to. And the way we're going to do that is by completing the square. So I group my x's together here. I group my y's together, and I get ready to complete the square. So I'm going to complete the square with the x terms and with the y terms. And in both cases, what we need to do is we need to make sure that the squared term has a coefficient of 1. So I need to factor out the 144 here for the x's. See, I factored it out, and that leaves x squared minus 4x. See, because 144 times negative 4 is negative 576. So I I'm set up for the x's, now also for the y's. Now you have to really watch your bad self, because when you factor out this negative 25, that's going to mess with the signs in here. So notice I factored out the negative 25, and that leaves a positive 8y. See? Because when I say negative 25 times a positive 8y, I get negative 200. So you have to be careful with your signs. Now, I'm going to complete the square. I take half of the negative 4, square it. Now, I added a 4 here, but really it's 4 times 144. So to keep it balanced, I add a 576 over here. Now, I do the same thing here. I take half of the 8, get 4, and square it, and get 16. But it's really negative 25 times 16, which is negative 400. So I have to subtract a 400 over here to keep it balanced. Then I can rewrite. Okay, so instead of this, I can write this as x minus 2 squared. Instead of this, y plus 4 squared. Now, I don't really have it in the form that I want, because I want a 1 over here. So let me just divide by 3600 and simplify this. And here's what I get. 144 over 3,600 simplifies to 1 over 25. 25 over 3,600 is 1 over 144. And just to be clear, I'll write 25 as 5 squared, 144 is 12 squared. Now we can find the parts that we're interested in. The center. The center, we're going to get the x-coordinate and the y-coordinate. The x from the parentheses with the x, the y from the parentheses with the y, and we get 2, negative 4. See? Dig that. 2, negative 4. Now, as far as the vertices go, now this particular hyperbola has a horizontal transverse axis. So we're going to add and subtract from the x-coordinate. And in fact, we're going to add and subtract 5. See? So 2 plus 5, 2 minus 5. 5 comes from the square root of that. Now, as far as the foci goes, we need to find the c. We take the 5 squared plus 12 squared, take the square root of that sum, and we get 13. So we add and subtract that from the x-coordinate. Now, as far as the asymptotes go, here's what's going to happen. Notice, let's look at the y's. We're going to take this number right here, only the opposite. It's going to be negative 4 plus or minus 144, well, the square root of that, which is 12, over 5, x minus 2. See? Look at that. Notice where these numbers come from. Here's negative 4. Here's 12 over 5. See that? 12 over 5, x minus 2. Those are the asymptotes. So that's how we can get each of the parts.